So the latest craze on YouTube woodworking stuff is running a smaller blade in your table saw, and the most common small blade is a regular circular saw blade. Now those are multiple sizes, but the standard for a full-size normal circular saw is a 7¼ inch versus the most common table saw is a 10 inch unless you get to a really huge 12-inch table saw, which most of us are never going to have. So general cost comparison, I like Diablo blades. Black Friday Christmas season specials. This 2-pack this year was $12.88. In years past it's been closer to $10, but hey, it's COVID and shortages. Alright, so let's round that up to $13. That's $6.50 per blade. Going to a Diablo, just sticking with an apples to apples comparison of like quality blades, depending on tooth count, you could be $30 to $40 to $50 for a single 10-inch blade. So let's say at the low end, a $25 blade, that's more than 3 times the cost for a blade. So the power gain you'll get from going to a smaller blade, a lot of people think that it's the mass of the blades. Now, you could break out a scale and you could weigh these, that the smaller blade is going to be a whole lot lighter. And startup power draw, that's going to be true, right? When electric motor starts, there's a huge power draw there, and this is why air conditioner compressors have start capacitors. Next small contributor, and scientifically it's significant, we know we've got wind resistance, so the bigger blade is going to catch more air. Sure, makes sense, more wind resistance. But the big thing is when you're in the cut, how much thinner the kerf is, and the kerf would be the tooth width on the blade. Significant difference here. And if we think about that difference, that's exactly the reason why a table saw is so much more efficient than a router. There are some cuts that you can't make with a table saw, and a router makes sense. Round over some panel joints. But in general, if you can do it with a table saw, maybe it takes you a little more setup time, it's going to be more efficient. And the reason is, with a router, if you cut out this groove here, you've got to cut out 100% of that material. But if you take the same thing with a table saw, you can make one cut this way, you can make one cut this way, and one cut this way, and the only material you have to cut is the thickness of the blade, or the kerf, in 2 separate cuts. So it takes a whole lot less power, it's a whole lot less wear on a bit or a blade. So that same thing carries over for kerf thickness on the blade. By reducing the thickness of the blade, you've reduced the amount of material that you've got to actually cut. And if you need a 10-inch in a thin kerf, Freud also sells, they don't actually market it as Diablo, although it's the same company. It's the Freud or Fruit, I don't know. You're going to psychoanalyze me, or the saw. It's Signum. Alright, made in Italy. They are pretty good blades. Their industrial line, they do have thin kerf in various tooth counts. But these blades are a whole lot more expensive than a standard 10-inch blade. So when you look at that, unless you need a depth of cut, a thin kerf 10-inch blade is a money-losing proposition. So a standard blade, the typical standard is an 1/8 inch thick kerf. And if you take a caliper and measure that, you should get about an 1/8 inch. And make sure you measure the actual teeth themselves, not the body of the blade. And if you go to the thin kerf, they're advertised as 3/32. So an 1/8 is 4/32. So you're gaining a whole 32nd here. So if I measure the kerf thickness of the 7¼ inch blade, I get a 1/16, which is another third smaller than the thin kerf 10-inch, which puts us at half of what the standard blade width is. So not much different than comparing a router to a table saw for efficiency of cut. If you can cut the amount of material that you're passing the blade through in half, it's almost a no-brainer for efficiency. Besides the efficiency gain, which is the equivalent of having a much larger, more powerful saw, and saving on the cost to run it and electricity, is what if you're ripping down, standard 1x stock to put in cutting boards, and this is walnut. If I have to give up an 1/8 inch of material to make that cut versus a 1/16, that gives me a whole lot more material to make use of. I have a whole lot less material loss with that smaller blade. So the first thing about using a thinner kerf blade, and this would be true of the 10-inch thin kerf or going to the 7 1/4, is you can't run your riving knife. Unless you machine it down or grind it down, the riving knife is sized for a standard 1/8 inch thickness blade. And so if you've got that hanging back there, your cut piece is not going to pass around that riving knife. It's just too thick. The next big downside is your maximum depth of cut. And you're really only going to get 1.5 inches absolute maximum. And for almost everything, that's fine. If we were to look at cutting this board here, if I need to cut it right here, it's obviously too tall. But that's not a cut I want to make anyway. Why would I stand it up here? That puts me more exposed to a tall blade and more likely to wobble, right? It's harder to hold this board stable if I've got it up like this. I'm going to turn it and cut it flat. So even if you're dealing with true 5/4 1 inch thick stock, you've got plenty of blade depth. And you're probably going to cut it laying flat. So for probably 99.5% of the stuff I do, and any large ripping batch jobs, it's more than sufficient maximum blade height. Another downside might be when cutting rabbets. Now, not a big issue here. This is not fine furniture for one, but two, since this is at the end, I'm able to make one cut this way and then turn it up and make the other cut. But if this were in the center of the board and I had to make multiple passes, a smarter move would probably be a dado blade anyway, dado set or dado stack, or a router bit. But on a table saw, you can get flat top blades in standard sizes. And that is to say that the typical blade, the teeth alternate like this. So instead of being straight in a line and flat on top, there's an angle at the top. And so that in total they make the kerf width, but the individual teeth themselves are angled. So if you're doing joinery cuts like that, you want a flat top blade. And unfortunately, with a 7 1/4, you cannot find flat top blades. So that would be another downside. Another situation where you wouldn't want to use it. But really, outside of those three things, inability to use the riving knife, limitation on the depth of cut, and no flat tooth blade option, outside of those three things, this will cost you so much less long term to run the smaller blade. You'll gain the equivalent of having a more powerful saw. It'll cost you less to run it from an electricity use standpoint. There's almost no real downside to doing it. How many teeth per inch? So a 24 tooth, which is the most common 7 1/4 inch blade, is a slightly coarser or fewer teeth per inch than a 36 tooth 10 inch blade. And you may think, well, man, that's going to give me a rough cut. But there are a couple of factors at play here. One, on that smaller blade, you've got less deflection, less wobble, less chatter. Two, you're going to build a whole lot less heat because you're losing less material, which means you're less likely to burn the wood. And as another consequence of cutting less material, you're able to keep your blade speed up even with a standard saw that maybe you're pushing a little hard. So you'd be surprised that the thought about tooth count and cut quality doesn't directly translate when you can keep your saw speed up